Hello children, in this video I am going to explain about the chemical properties of carbonates compound which is there for grade 10th standard. For it is very important for any state board students, okay, and CBSE students, CBSE 10th students. Okay, so what are the topics we are going to cover? We can see here. First is what are chemical reactions. Chemical reactions of organic compounds. So there are four reactions they have given. First is what? Combustion reaction. Next is what? Addition reaction. Third one is what? Substitution reaction. And fourth is oxidation reaction. So we are going to cover these four important reactions. Let's start with the combustion reaction. Combustion means what? Burning. Anna. For example, when you burn the coal, what will get? Simply once you burn coal is carbon. When you burn the coal, so react with oxygen gives you what? CO2, right? Gas. But in this case, in the case of hydrocarbon, if you take any hydrocarbon, let's take methane, CH4. When it burns with oxygen, okay, it always gives us CO2 plus H2O plus heat and light. Heat and light. So any hydrocarbon, whether it is a methane, methanol, okay, we'll see. How many hydrogens are there? There are 4 hydrogens. So this side 2. So multiply by 2. So 2 to the 4. Carbon 1, carbon 1. Oxygen 2 and 2, 4, right? So multiply by 2. Okay. So methane is what? Gaseous state. Oxygen also gaseous state. Then this will be in gaseous state only. Water. If you take another equation, let's take example of combustion of ethanol. Ethanol is what? CH3, CH2, OH. What will happen when it burns with oxygen? Okay, it will give you again same thing. Product is same. CO2 plus H2O plus heat and light. Okay. How many carbons are there? 1 and 1. 2 carbons. So multiply by 2. Okay, hydrogen 3 plus 2 plus 1. So it is 6. So multiply by 3. 3 to the 6. Now oxygen 2 to the 4 and 3 into 1, 3. 3 plus 4, 7, right? This side 1 is there. But here you multiply by 3 in gaseous state. So 3 to the 6 plus 1, 7 there. This is balanced. So now similarly we take the another equation, ethanoic acid, CH3 COOH. When it burns with oxygen, what will happen? Then it will give you the same product, CO2 plus H2O plus heat and light. Heat and light. Now see how many carbons are there? There are 2 carbons, right? Multiply by 2. 2. Now hydrogen 3 plus 1, 4. Multiply by 2. Oxygen 2 to the 4 and 2, 6, right? This is 2 already there. So multiply by 2. Get clear? This is the example of combustion reaction. You should know there are 2 types of combustion, children. One is complete combustion, other is incomplete combustion. Okay. So complete combustion takes place in the presence of air, when air is present in uh, adequate amount, right? Where incomplete combustion means what? Whenever air is present in limited supply or insufficient supply of oxygen is there, then incomplete combustion takes place. Incomplete combustion. Okay, in this case, incomplete combustion means in the limited supply of oxygen or in absence or limited supply of air, especially oxygen. Okay. In this case, any compound will burn with a sooty flame, and or it is a yellowish flame. yellowish flame. Okay, but whenever the complete combustion take place, children, in the presence of air, okay, so that is bluish flame. In the complete combustion will take place in the presence of oxygen. Okay, oxygen is present in adequate amount. So in that case, bluish flame. This is bluish flame. A clean flame, we can say. Okay, due to take place in the presence of oxygen, adequate amount of oxygen, presence of oxygen over here. Is it clear? Next is what addition reaction. Next type of reaction is what addition reaction. Let's see. Addition reaction. And the question I'm going to explain addition reaction. Addition reaction. Okay, generally addition reactions, okay, are performed by unsaturated hydrocarbon. This takes place in alkenes and alkynes. Okay, this takes place in alkenes generally wherever double bond is there or triple bond is there, alkynes. Okay, let's take one example, ethene, CH2 double bond CH2. Okay, what is this? Ethene. Okay, it is a alkene, right? Whenever ethene react with hydrogen in the presence of catalyst, nickel catalyst or platinum, you can take. What will happen? One hydrogen comes here, one hydrogen comes here, right? So it will form what? CH3 single bond CH3. So ethene changes to ethane. Ethane. Okay, now so this is ethene. What is ethene? So this is ethene. Ethene. Okay. Similarly, if you take ethine, CH triple bond CH. When it reacts with hydrogen, so ethine will change into one hydrogen comes here, one hydrogen comes here, right? It will change into ethene first. CH2 double bond CH2. Okay. And if you take CH triple bond CH react with two molecules of hydrogen. Okay. Two. So two hydrogen comes here, two hydrogen comes here. So it will form what? Ethane. CH3 single bond CH3. It is what? Ethane. What is this? This is ethine. This you see CH triple bond CH. Okay, it is what? Ethine. Ethine changed into ethene. Is it clear? So this always takes place in the presence of catalyst. Okay, any catalyst is required. Okay, like nickel, platinum, palladium. Okay, palladium is PD, platinum is PT. Okay, where we are using this application, children. Okay, addition reaction. It is in the applied in the hydrogenation of vegetable oil. Here we are using hydrogenation of vegetable oil. You see how it is. Hydrogenation of vegetable oil. Okay. Hydrogenation of vegetable oil. Hydrogenation of vegetable oils. What is the formula for vegetable oil? R C double bond C R R R. What is R? Being a good student, you should know R is a alkyl group. R is what? Alkyl group. Okay, alkyl group. The general formula for alkyl group, alkyl group, children. Alkyl group. The general formula for alkyl group is what? CnH2n plus 1. Okay, for example, you can say if you put n is equal to 1, you will get CH3. Okay, methyl. If you put n is equal to 2, you will get C2H5, ethyl, like that. So here R is a large hydrocarbon. What happens? This is the formula for vegetable oil. Vegetable oil. whenever it react with the hydrogen in the presence of catalyst nickel. So what happens? One hydrogen comes here and one hydrogen react here, right? And double bond will break into convert into single bond. So we can write R. Okay, R. The hydrogen comes again. See, where the space is less. 1 second. We'll delete here this one. So now you can see, okay, CRR, H is joins here again, CRRH. So this is the formula for Vanaspati ghee, children, or dalda. Vanaspati ghee or dalda. Okay, so here it is a double bond is there in vegetable oil, and it is single bond is there between carbon carbon. Okay, see, generally nickel is a metal, right, which is not good for health. Okay, because of this metal catalyst, okay, it causes the blockage in the arteries. So it is a very dangerous. Okay, and it may lead to the regular consumption of Vanaspati ghee or dalda leads to the heart attack. Okay, so but it is a cheap quality of ghee, we can say. Okay, which they are using the roadside dhaba generally. Okay, so we should not consume this dalda, children. Okay, it is not good for health. Why? Because it contains catalyst, metal catalyst like nickel, platinum, which is not good for health. The next reaction is what? A substitution reaction. Okay, third reaction is what? A substitution reaction. Generally, substitution reaction takes place in alkanes only. Okay, alkanes where single bond is there. Let's take one example, CH4. When it react with the chlorine in the presence of sunlight. In the presence of sunlight. So what happens? One hydrogen is substituted by one chlorine atom. So it form CH3, single bond Cl plus HCl. So it will form what? A chloromethane. Cl is what? A chloro. So chloro, it is halogen, right? One carbon is there means methane. Chloromethane. Okay, so this is the substitution reaction. Again, if you pass, okay, chlorine with this compound, okay, CH3 Cl plus again Cl2 is passed in the presence of sunlight. So again, one hydrogen is substituted by one chlorine atom. So it form CH2, then Cl2 plus HCl. In this case, what will happen? Dichloromethane. Two chlorine is right, so dichloromethane is formed. Dichloromethane. Dichloromethane. Again, if you pass the chlorine CH2, Cl2, again chlorine is passed in the presence of sunlight. Okay, so one hydrogen is substituted by one chlorine atom. So in this case, CHCl3 is formed plus HCl. What is CHCl3? It is nothing but a trichloro. Three chlorine is right. You can use the prefix tri. Trichloro. One carbon is there means methane. Okay. Again, if you pass chlorine with this compound CHCl3 plus Cl2 in the presence of sunlight. Okay. So you can see again this hydrogen atom is substituted by one chlorine atom. So it forms CCl4 plus HCl. This is what tetrachloromethane. What is the tetrachloromethane? Because four chlorine atoms are there, right? That's why we are using tetrachloro. Why methane? Because one carbon is only there. Is it clear? So this is the example of substitution reaction. Okay, this is the example of substitution reaction. Okay. Suppose let's do one problem. If they give in the exams, complete the equation. CH3, CH3. Okay, that is what? Ethane. What will happen when chlorine is passed in the presence of sunlight? In the presence of sunlight. So again, one hydrogen is substituted by one chlorine atom. So we can write a CH3, CH2, Cl plus one hydrogen and one chlorine will form HCl. So how we are going to name? This is chlorine, right? So we'll use the prefix chloro. How many carbon atoms are there? One and this one, two. So chloroethane. Chloroethane. What did you say? Here ethane is there, right? So whenever you pass a chlorine, so again if you give a, okay, so if keep on passing the chlorine atoms in the presence of sunlight, then again substitution will keep on happening. Okay, but here if only one time, so only one time substitution you have to show. Is it clear? Okay, next reaction, fourth reaction is what? Oxidation. Fourth is what? Oxidation reaction. What happens, children? This is there in the syllabus. Okay, in this case, ethanol is changed, oxidized to ethanoic acid in the presence of oxidizing agent. Okay, so let's take example, ethanol. What is the formula for ethanol? CH3, CH2, OH. Okay, that is ethanol. What is the condition here? Here we are using oxidizing agent like a alkaline KMnO4. It is a very good oxidizing agent, children. Or acidified potassium dichromate K2Cr2O7. What happens? Hydrogen is removed and oxygen is added. They provide the nascent oxygen. So we can write as it will form CH3 COOH. This is what a ethanoic acid. Ethanoic acid. So what is this? Ethanol. Ethanol changes to ethanoic acid in the presence of oxidizing agent. This reaction is called as oxidation reaction. Okay. Let's take some more reactions in this video. Here, children, in your syllabus, we have in CBSE 10th especially, we have ethanol and ethanoic acid. So we are going to discuss okay, ethanol and ethanoic acid. Let's take ethanol first. Okay, there are 2-3 reactions are given. Ethanol. Okay, what is the formula for ethanol? C2H5OH. Okay, what is the functional group? Okay, or we can represent like a CH3 CH2OH. Okay, first reaction. Okay, reaction with metal. Reaction with metal like sodium. Okay, let's take us ethanol CH3 CH2OH. Whenever it react with sodium metal, children, okay, what will happen? This hydrogen gas is evolved. This 2Na will combine here. Okay, and hydrogen gas. So two molecules of ethanol you have to take. Found 2 molecule of CH3 CH2 CH3 CH3 CH2ONA CH3 CH2ONA. That is sodium ethoxide. The name is what? Sodium ethoxide plus hydrogen gas is evolved. Okay, you should know, children. Okay, first this is the ethanol, second member of this alcohol, right? First member is what? Methanol, CH3OH. Methanol is highly poisonous. Okay, methanol is mixed with ethanol to make it poisonous. Okay, to avoid it's a misuse. Okay, so this process is called as denaturation of ethanol. Okay, if you mix little amount of methanol to ethanol, it becomes poisonous. It is highly poisonous. Methanol is what? Highly poisonous. Highly poisonous. Get clear? So first reaction of ethanol is what? Reaction with sodium. It gives you sodium ethoxide plus hydrogen. Next we see dehydration of ethanol. Dehydration of ethanol. D means water removal. Hydration means water molecule. What happens whenever concentrated sulfuric acid is passed? Okay, at 443 Kelvin. Okay, so ethanol is changed into ethene. We'll see what happens. CH3, CH2OH. What is the condition for dehydration? Concentrated conc H2SO4, okay, at 443 Kelvin. At this temperature, 443 Kelvin. Okay, so this will lose a molecule of water. So H from here and OH from here is lost. So what it form? CH2 double bond CH2 plus H2O is formed. So ethanol changes into ethene. This reaction is very, very important. Okay, dehydration of ethanol. Is it clear? What is the condition? Conc H2SO4 at 443 Kelvin. If you want to write in degrees Celsius, you have to subtract how much? 273. So once you subtract, you know how to convert, right? Kelvin is equal to degrees Celsius plus 273. If you want in degrees Celsius, so degrees Celsius is equal to K minus 273, right? In Kelvin it is 443 minus 273. If you do, you will get 170, or we can say 170 degrees Celsius. Okay, dehydration of ethanol. Oxidation, already we learned. Oxidation means what? Ethanol changes into ethanoic acid. Okay, in the presence of oxidizing agent. Here one can see we have covered here only oxidation. Ethanol combines with okay, ethanol changes into ethanoic acid in the presence of alkaline KMnO4. Okay, one more is the esterification. We'll discuss in ethanoic acid only. Okay, reaction of ethanol with ethanoic acid. Is it clear? So this we have to focus. Next we have is what? Ethanoic acid. Next is what? Ethanoic acid. Ethanoic acid. What is the functional group in ethanoic acid? Carboxylic acid. Okay, COOH. Okay, formula for ethanoic acid is what? CH3 COOH. See, as 1 and 2. Two carbons are there means ethane. For this suffix we are using oic acid. So what is called as ethanoic acid. Is it clear? It is also called as glacial acetic acid. Glacial acetic acid. Why it is called as glacial acetic acid? Because it has a freezing point of 17 degrees Celsius. So at this temperature, okay, during winter, it will crystallizes into solid. Okay, like that's what it is called as glacial acetic acid. It becomes converted into solid state. Okay, at this temperature, it looks like ice. Okay, in the glaciers are there, right? How it looks icy, no? So like that only, it will freezes into ice. That's why at this temperature. Okay, so this is very common temperature in winter, right? That's why it is called as glacial acetic acid. Common name of ethanoic acid is what? Acetic acid. Other name is what? Common name, acetic acid. Acetic acid obtained from vinegar. Yes or no? Now we will focus on chemical properties. Okay, chemical properties of ethanoic acid. Chemical property. As it is an acid, children, so it will undergo all the reactions of acid, like reaction with a metal, reaction with a base, okay, reaction with metal carbonates. Is it clear? So we are going to discuss one by one. This is reaction with sodium, reaction with metal, reaction with the metal. Reaction with metal. Let's take CH3, COOH, ethanoic acid, react with the sodium. Generally, what happens? Any acid react with the metal, it gives you salt plus hydrogen, right now. So here you take two molecules, here also you take two molecules. You form two molecules of CH3, COO, Na plus hydrogen gas. So this is sodium ethanoate. Okay, it is a ester. Sodium ethanoate. Ethanoate. Or we say sodium acetate. Because acetic acid is there, so we can say sodium acetate. Okay, so this is what. Okay, whenever acetic acid react with the sodium, form sodium acetate plus hydrogen gas is evolved. You can see. Next reaction is what? A reaction with the base. Okay. The reaction with the base. The reaction with the sodium hydroxide, NaOH. NaOH is what? A base. As you know that whenever acid react with a base, what will give you? It will always give a salt and water. Yes or no? So here also it is the same case. So generally we know that whenever any acid react with any base, it generally gives a salt plus water. Salt plus water. This reaction is also called as neutralization reaction. So you can see CH3 COOH. Whenever it react with NaOH, will form salt. What is salt? Na will come here, right? CH3 COO CH3 COO plus H for OH from here and H from here will form water, H2O. So again, the product is what? Sodium S, ethanoate. Or you can write sodium ethanoate or acetate. Ethanoate. Is it clear? Next, third reaction is what? Reaction with ethanol. Very, very important. This is 10 star. Very important. Reaction with ethanol. Reaction with ethanol. The reaction of ethanoic acid with ethanol is also called as esterification reaction. Very important reaction. Esterification reaction. What happens in esterification reaction? Ethanoic acid react with ethanol. Okay, it forms fruity smelling compound called as ester. Okay, so ethanoic acid is what? CH3 COOH. Ethanol formula CH3 CH2OH. Okay, here we are using a conc H2SO4, concentrated H2SO4. It acts as a catalyst, we can say. Okay, what will happen? CH3COO ester is formed, children. CH3COO, this and CH2CH3 joins. So this is ethyl ethanoate. Ethyl ethanoate. This is only fruity smelling compound called as ester. Okay, plus you see, children, OH from here and H from here will form water. Water is released. This reaction of ethanoic acid with ethanol, okay, in the presence of conc H2SO4 is to form ester is called as esterification reaction. Okay, ester is very, very useful. It is used in perfumes. It is also used okay, in ice creams to provide the artificial this one flavor. Okay, flavor, you know, like fruity smelling compound. Yes. So to provide whatever the ice creams you're eating, which is having fruity smell, artificial, that is only contain ester. Is it clear? So this is the reaction of ethanoic acid with ethanol. This is CH3COH is what? Ethanoic acid. So let's write. Okay, ethanoic acid. Okay, and what is this? Ethanol. Ethanol. Is it clear? Next reaction is what? Reaction with metal carbonates. Okay, reaction with metal carbonates or bicarbonates. Reaction with metal carbonates or metal bicarbonates, carbonates or hydrogen carbonates. We also say bicarbonates. Bicarbonates. What happens? Generally, acid react with metal carbonates or bicarbonates. It gives you salt plus carbon dioxide plus water. Same here. CH3 COOH. When it react with the sodium carbonate, Na2CO3, so what will form? Salt, that is CH3 COO Na, that is a salt, sodium acetate or ethanoate plus H2O plus CO2 is formed. See, CH3CO and Na will join. Okay, yes or no? So two molecules you take two molecules. Okay, and 2H and O will form H2O, that is water, and CO2 will form, right? Even if you take a bicarbonate CH3COOH, when it react with the sodium bicarbonate NaHCO3, the same product is there, children. CH3COO Na plus H2O plus CO2. Is it clear? This is the reaction with the metal carbonates and bicarbonate. One reaction is there, saponification reaction. That is also very, very important. Saponification reaction. Okay, it is a reaction of ester with sodium hydroxide. Here we have formed, right, ester. How we have formed ester? We have formed ester here in this equation, esterification reaction. In saponification, what happens? This ester, that is CH3, COO, CH2, CH3. This is ester react with NaOH. Okay, it will form what? See, CH3, CH2, OH will form ethanol. First, you write this CH3, CH2, OH, that is ethanol. And this CH3, COO, and Na will form sodium salt of ester. CH3, COO, Na. See, this is a, we can say, soap actually. How it is a soap? If you see the formula for soap, children, soap is nothing but the formula soap can be represented as RCOO, Na. Okay, here R is large. Okay, here this is what is the CH3COO, Na. You can represent this is what R, alkyl group. In case of R, this is what soap C17H35 COO, Na. Right? The same procedure is used to form the soap. That's why it is called as what saponification reaction. We are taking the ester reacting with the NaOH gives you sodium salt of ester. That is nothing but a soap, right? So that's why it is called a saponification reaction. Along with that, ethanol is formed. Okay. One question they will ask you, how if there are two beakers are there. Okay, in one beaker, suppose ethanol is there, another beaker, ethanoic acid is there. Okay, suppose this is CH3COOH, ethanol. Sorry, ethanoic acid. Okay, another beaker, it is ethanol, C2H5OH. How are you going to identify? So one we can identify with a litmus test. Okay, litmus paper. Once you dip a blue litmus into the acid, it turns a blue litmus red. Ethanol, it will not give. Okay, litmus test we can do. Another is what? If you add a sodium carbonate salt. Okay, and if you are getting a brisk effervescence, okay, sodium carbonate or bicarbonate. So we know that ethanoic acid only react with sodium carbonate. It gives CO2 gas, right? Now, so brisk effervescence of CO2 is observed. It means it is a ethanoic acid. If it is not observed, it is ethanol. Is it clear, children? So if you like my teachings, then you can share with your friends. Okay, subscribe the channel. Okay, thank you, children. I hope I cleared the important reactions. Thank you so much.